It's one of our ultimate questions. And until recently, we couldn't even ask it. How many universes exist? Is this a trick question? Well, if we define universe as everything there is, then sure, there can be only one universe. But if we define universe as everything we can ever see, no matter how large our telescopes, then many universes may exist. Talk about expanding our horizons. There is nothing in science more majestic, more awesome. To know what's real, I must start here, with multiple universes. I'm Robert Lawrence Kuhn, and this is Closer to Truth. If multiple universes exist, no one can picture them better without number or end than Andrei Linde. Andrei's originally from Russia, and his vision of the cosmos is astonishing. We meet at Stanford's Linear Accelerator. Andrei, 50 years ago, to ask the question, how many universes are there, would have sounded absurd. Can I ask you the question, how many universes are there?
Well, the answer depends on what do you mean by the universe. The simplest definition of the universe is whatever it is. Everything is the universe. But right now, during the last few years, we start calling it a multiverse. And the reason why we changed it, the name is that well, we have found that our own universe can be divided into extremely large regions, and each of these regions have different properties. But if you live in one of them, it is so large that you make measurements around, you never see this other part because it's so far away from you.
Now, everything we see that goes back almost 14 billion light years, everything we see is still our local piece of this.
Right. This goes back to the question why our part of the universe is so large. It's billions of billions of billions of centimeters. But from the point of view of inflation, it's a minuscule part of a huge multiverse. And then if you go even further, you will see a different part of the universe with different properties, different people or not people, or somebody else living or not living there, enjoying or not enjoying life.
That's a very significant point. Do you mean literally the laws of physics could be different?
Well, again, just like with the definition of the universe, the definition of law of physics is something should be explained. Like, for example, you have water, okay? So it's the same thing, water, chemically, but there is liquid water, there is solid water, and there is vapor, okay? So it looks completely different. Fish can live only in liquid water. So just imagine that you have our Earth, and there is an ocean there, and there is these icebergs there, so fish cannot live in the iceberg. Now just imagine that you have this iceberg of the size of the universe. So we cannot live there, but we can live in a place where you have this liquid something. And this is what is shown here on this picture. This is our universe, looking like a huge fractal consisting of different extremely large parts. When you live in each of these parts, here or here or here, for you it will look like almost infinite universe. But if you continue going from one balloon to another balloon, something may change. And I use here different colors to show that in each of these universes you may have slightly different laws of physics. And these parts of the universe are suitable for life of our type, and these parts are completely unsuitable for life of our type. But maybe even this is not the limit. Maybe you have one fractal like that, and then completely different fractal in its own space, growing separately. This will be completely disconnected universes, maybe with totally different fundamental laws of physics. I think that this is a way of future. We need to go to these more abstract stories. But as of now, we are dealing with this, and this is already abstract enough.
Andrei's balloons are pretty, but what they mean is startling. Each of Andrei's balloons is a separate universe, each with different laws of physics. And the whole ensemble of universes, the multiverse, is incomprehensibly vast and growing ever more so. But how could multiple universes be generated? The person most responsible for discovering how multiple universes may form is Alan Guth, whose theory of cosmic inflation revolutionized cosmology. Alan's inflation may be one of the most important ideas ever. We meet at MIT, our alma mater. Alan, what are some of the mechanisms by which multiple universes could possibly be created?
Certainly one of the mechanisms that can generate multiple universes comes out of inflation. It proposes that our universe began with a period of exponential expansion driven by a peculiar kind of material that actually creates a gravitational repulsion, which is what causes this exponential expansion. Now, the reason this leads to multiple universes is that the process by which it decays is really very similar in nature to the process by which any radioactive substance decays. And as we all have heard since grade school, radioactive things have half-lives. And that means if you wait a half-life, on average, half of the material will have decayed and half will remain. And you wait another half-life, again, half will disappear. But there's a catch here, which is that this repulsive gravity material is, at the meantime, undergoing exponential expansion at the same time that it's decaying. And this exponential expansion is much faster than the exponential decay. Indeed, the half that remains, because of its exponential expansion, will in fact have a larger volume than what you started with, and in fact a vastly larger volume. So even while you're watching it decay, it's growing in volume exponentially. So pieces of it decay. Each piece that decays produces a local effective universe, which we usually call a pocket universe. But at the same time, when one piece decays, another piece nearby does not decay. Only half of it decays in a half-life. So the pieces that don't decay go on exponentially expanding, and they decay in pieces later, continuing to produce these pocket universes, literally ad infinitum. If this picture is right, we see no end to it. It appears that it's going to produce literally an infinite number of pocket universes, each one of which, by the way, would be on average at least vastly larger than our observed universe. So our observed universe would just be a small speck within one of these pocket universes.
So let me just get some things straight. First of all, when you're using this term pocket universe, that's a big thing.
Yes.
It's a pocket because it's distinct from all these others that are developing.
That's right.
And that enables us to generate multiple universes, these pocket universes that get squeezed off from one another.
That's right.
Each one of Alan's pocket universes is vastly larger than all we can ever see, which is only our local part of one pocket universe. And new pocket universes form so rapidly that there may be infinite numbers of them. I am dazed. I need perspective. I turn to Martin Rees, the UK Astronomer Royal, whose literary vision parallels his rigorous science. We meet in his home at Cambridge University. Martin, suddenly we now have multiple universes, which just takes your breath away. Is this just fiction, or could there really be multiple universes?
Well, it's speculation, but I would say it's speculative science and not just metaphysics. And I think we may be in for a conceptual leap, rather like early leaps in the past, because we've gone over history from a view of the geocentric universe, Copernican universe, the idea that we have a Milky Way galaxy, and then the idea since the 1920s that that galaxy is one of billions. But we may be led to the idea that there's far more to physical reality than the vast domain that we can see through our telescopes. The reason for that is that the gradient across that domain is so tiny, it would be amazing if the universe didn't extend thousands of times beyond what we can see. The fascinating option is that there are these other universes, and they're governed by different physical laws. Space may be different, gravity may be different, atoms may be different, but only some tiny subset of them would be governed by laws that allowed complexity to evolve. Most would be sort of sterile because gravity was too strong to allow complex structures, because atoms weren't stable, or for some other reason. The most fascinating option, of course, is the idea of many Big Bangs displaying an immense variety of physical laws, because then science fiction is the only limit to what might happen.
But to achieve that, there has to be, at some deeper level, some series of laws in order to generate all the multiple universes that have different laws. Does that make sense?
Oh, indeed, there would be a set of fundamental laws, but what we have thought
To be the fundamental laws
are just sort of
Right.
secondary parochial
Expressions.
consequences, as it were. Yes, if we had that fundamental law, it would tell us what variety was possible in the local bylaws, what numbers of dimensions, and what range of possible laws governing atomic physics, etc. I find that a rather grand and fascinating concept, even though it means we're further from being able to grasp the final laws. But as to which way it'll pan out, then I think we have to ask these two questions. First, is our Big Bang the only one? Yes. And secondly, if there are many Big Bangs, are they all governed by the same laws, or do they display immense variety?
Martin's two questions are profound. Was our Big Bang the only one? And if our Big Bang was not the only one, do the others have different laws? If there are multiple universes, and if the laws of physics are different in each, how could those different laws be generated? Is string theory the answer? I ask Leonard Susskind, one of its originators. We meet in his home near Stanford University. Leonard, the concept of multiple universes have really revolutionized our understanding of how big reality can possibly be. How have you incorporated those ideas into your worldview?
The idea of multiple universes is basically that inflation is a mechanism for creating all the diversity in different places in the universe that is possible. Those ideas will lead to a universe which is populated by many, many bubbles, but the question is, how many different kinds of bubbles are there? What string theory brings to it is something about the number of possibilities, but it's numbers which are far, far bigger than the number of atoms in the universe, far, far bigger than anything you can think of. The number 10 to the 500 gets bandied about a lot. Not 10 to the 500 different little pocket universes, but 10 to the 500 types of them, each one being repeated over and over again.
Okay, let's take the situation of these multiple universes being generated chaotically by inflation, and these 10 to the 500th approximately possibilities that string theory can have. Which generates the other?
I don't think it's a question of cause and effect of one and the other. They're two separate things. The space of possibilities, in other words, the collection of all possible kinds of universes that can exist, it is very similar in a way to the space of all possible kinds of creatures that can exist. And that's very big.
And that's string theory.
That's string theory.
That's the 10.
So, on the one hand, string theory gives you the analog of the different number of ways of rearranging a DNA molecule.
Okay.
Right? What inflation brings to it is the other side of the coin. How do you bring these different universes with different DNA, how do you bring them into existence? Eternal inflation creates more and more space, and that space simply just fills up all of the different possibilities that are inherent in the equation.
As you see these two fairly powerful theories in today's world, how do you see progress being made? Do you see next
Oh
steps?
boy. There are two kinds of progress that you can imagine. One is at the theoretical level, and one is at observational, experimental level. Theoretically, I think we will simply learn to explore this landscape better and better. We may be able to figure out which combination of these elements put together in various ways create a universe like our own, and check that there is such a possibility. We may also be able to better understand the mathematics of this eternal inflation. Now, you have to find some way of confirming this by observation, and that's where the hard stuff is. What we may be able to do is to look into the past, and by looking into the past, discover that our universe was born from one of these bubble nucleations. This is possible, but quite frankly, the experimental possibilities are very limited and very, very hard.
So string theory would give Lenny his landscape of all possible laws of physics. And cosmic inflation would generate actual universes to populate that landscape with things that really exist. That's quite nice. The smallest relationships expressing the largest substances. Max Tegmark is a rational family man in his private life, but a radical visionary when posing multiple universes. What he thinks seems incredible. Originally from Sweden, Max is now at MIT, where we meet. Max, we hear today about multiple universes. Are they just some wild philosophical idea, or are there real physical mechanisms by which we can hypothesize that they actually can work?
And the amazing thing that we've discovered is that it's extremely hard to make only what we see, to make only this part of space from which light has time to get to us so far, and make nothing else, and then stop. The best theory we have for how to make this space is this theory of inflation, and it just keeps going and going and going. You start with a tiny amount of space, and then Einstein taught us that you can actually produce more space, stretch it out to make more gallons of space.
Okay, that's one mechanism to generate multiple universes. Are there other mechanisms?
Yeah, then there are the quantum parallel universes, which are more controversial, and they're very easy to make. Let me make some right here. If I balance this pencil perfectly on its tip like this, and if there were no air molecules disturbing it, then it would stay balanced forever, of course, by symmetry, right? But according to quantum physics, the Heisenberg uncertainty principle says that it will actually fall down, and you can do the math. It takes about 20 seconds, and it will fall down not in any one direction, because that would break the symmetry, right? It will actually fall down in all directions in this strange so-called quantum superposition. This is what the physics tells us, and that's how easy it is to create these quantum parallel worlds. You just have to take something which is very symmetric and then let the symmetry get destroyed.
How many different worlds would have been created by the pen falling in any one of the directions?
We just created a vast number of different worlds here. The more shocking question is, why is it that we never see things being in two places at once, at least when we're sober, right? If you take seriously this idea that the quantum equations, that's it, then all of these possibilities are actually played out for real. And in fact, the whole notion of randomness is just an illusion. Things feel random whenever our brains branch into several different states, because each one of them is going to think that only that happened and not the other. And I find it just incredible that one of the most beautiful ideas in all of science, that maybe the structure of the universe on the largest scales actually originates from the microscopic quantum world. And you might say, that sounds totally nuts. I mean, quantum is supposed to have to do with atoms and tiny things, not things on the scales of galaxies. But you have to remember that space has stretched out so dramatically, right, since this happened. that things which used to be smaller than an atom are now much larger than a galaxy. And this is, in fact, in my opinion, the best theory we have of how things started out.
Multiple universes by quantum branching? Have we gone nuts? Or perhaps our eyes are just starting to squint open. Perhaps there's more to see. Perhaps with the words of art, we'll see the fullness of science. I speak with Steven Weinberg, Nobel laureate and elegant expositor of science. Steve, do you have an aesthetics of multiple universes?
Well, of course, the word universe, I suppose, properly should be should mean the whole thing, everything. But we tend to think of universe, use the word sometimes just to mean our Big Bang, the things we can see out to 10 billion light years in all directions. And in that sense, it's an honest, reasonable question: is this unique? Are there multiple ones? And there could be multiple ones in many different senses. It could be as simple as the fact that the universe is bigger than we think. It's much bigger than 10 billion light years across, and that there are big bangs going off in different places. Then there's another possibility, which is also fairly simple to imagine, just that this Big Bang is one episode, and maybe it followed a series of other bangs, and that our universe will make a transition into a different kind of expanding universe, and we're just living through a particular age. But then there are other possibilities that are a little bit more recondite, and that have to do with the application of quantum mechanics to the whole shebang. Because the fundamental quantity in quantum mechanics is not the individual particle, but is something called the wave function that describes all possibilities. It may be that the universe, the big universe, the whole thing, is some kind of quantum mechanical superposition of different possibilities. Then there are even more exotic possibilities, the so-called principle of fecundity, according to which if you can imagine it, it exists. Everything you can imagine exists. They don't exist in the same space-time. They're entirely separate. And that avoids the question of why are things the way they are, because whatever you can think of, they are that way.
You've talked about beauty as a defining characteristic of not only good science, but the fundamental structure of the world. Is the picture you're now describing a beautiful one?
I would say a beautiful theory is one that doesn't have arbitrary assumptions, that isn't carefully tinkered with to make it match observations. And this is not, to me, as beautiful as a theory which is so logically constrained that it can only be one way. But, we don't necessarily get all the beauty in life that we hope for. But in the end, if the theory isn't beautiful, the hell with it. It isn't worth worrying.
Multiple universes make me dizzy. Yet there is something about their beauty which revives my spirit. But before exhilaration floats me off, I should touch the ground, review what I really know. If multiple universes exist, our worldview changes. Multiple universes can be generated, in theory, in at least 4 ways. 1. Different regions of our ordinary space and time, so far away that even its light, traveling with enormous speed, will never have time to reach us.
But then you can see also here very large
2. Different domains of ordinary space and time, squeezed off to become forever separate.
Everything that is possible within the framework
3.
of the equation.
Different dimensions of space and time, where in some higher dimensions, entirely separate realities may be very close, but forever apart. 4. Different world histories through the strangeness of quantum mechanics, where each observation causes all reality to split into many worlds. Multiple universes may be forever untestable, but when we consider their possibility, we come closer to truth.
For complete interviews and for further information, please visit closertotruth.com.